Hi guys, good afternoon, and we're going to solve a problem. Uh, we'll try to solve this one, and this is the problem. It's about TPC and density. The formula for TPC in brackish water is TPC times the present density over 1.025. So this is an example of a problem. So the vessel Nara is to load a maximum of 9 meters, and she has a present drop of 8.65 meters of a density of 1.01 1.01 1.012 is the density. And the question is how much cargo she may load to bring her to completion, her completion drop, meaning to gain this 9 meters drop, how much cargo would she load to reach 9 meters. So first things first is he wants the TPC of TPC of the drop of 8.65 in a density of 1.012. So we have to compute the density of this density. So this is the formula. So TPC is times local density over 1.02. This 34.79 is the TPC of 8.65. So we want to know the TPC of 1.012 rocket water. So by this formula, the TPC of 1 point density TPC of the density of 1.012 is 34.5, and I will show you how we can get this uh, TPC. Okay, so he says his present drop is 8.65. So, sorry, 8.65. Forward is 8.65. Up is 8.65. So his main drop is 8.65. His LCF is 0.60, MTC is 24561, and this TPC is 34.79. So this is the TPC of 8.69. But he wants the TPC of the density of 1.012, which is this one, 34.85. Okay. Now, assuming his mid port is 8.65, 65, starboard is 8.65. So his mid is 8.65. According to the uh, problem, that is departure drop or maximum drop is 9 meters. So we put 9 meters. So yes, a sinkage of 0.35. centimeters. So initial drop is 8.65 plus the sinkage is this should be his departure. Now, in actual practice, we don't use the TPC of the initial drop. We don't use this one. What we use is the TPC of the departure drop, which is interpolated. This will be the value of the TPC of 9 meters, which is 35.06. Again, I repeat, in actual practice, we don't use this TPC when we want to load to a maximum cargo. So what we usually do is of your departure drop or your maximum drop, you will get the TPC. You will use this TPC in getting the remaining cargoes. So the TPC of 9 meters is 36.2, which is already interpolated. So by this formula, TPC times your local density over 1.025. So TPC is 35.06 times your local density is 1.012 over 1.025 is your TPC of the density of 1.012. So this is now your PC. The question is how much cargo will you load to reach 9 meters? So to get the cargo to load, this is the formula. Formula is K9 is the rise or the sinkage times 100 times this TPC, which is this one, TPC of 9 meters. So by computation, this sinkage times 100 times your TPC, you get 12,212. So is his value, his answer is 1,202. I have I have 10 tons more. Because I'm using the maximum departure drop. While in this case is using only the present drop, TPC of the present drop, which is this one. So this will be his TPC of this density of 1.012. So this is my answer. In actual practice, we use this departure drop of 9 meters. So with this 10 TPC of 9 meters, which is this one, 35.6 multiplied by 1.12, this is the local density over 1.025, which is the constant. So your TPC for this density is 34.62. So with this TPC, you will get the cargo to load. So this is my answer. But the question stops here. But uh, for the sake of uh, actual practice, we want to load this one in the vessel. So this has only 4 vessels. So I want to load it in 1 and 4. So this will be the value to load in number of hatch number 1 and hatch number 4. 606 in number 1, 606 in number 4. And your departure draft forward will be 8.88 and your updraft will be 9.12 and your main will be 9 meters and you have a trim of 24. So this is your departure draft mid and 9 meters mid and you have a main of 9 meters, so you have a zero deflection. Okay, in actual practice this is this is what we do. Let's say your initial after you you after loading you're going out to have a trimming hold. Trimming hold is 1 and 4 and you have to stop because you want to know how much you're going cargo to load for trimming. So your initial drop was 8.65, 8.65 forward and up is 8.65. This is the actual practice. So with this draft, the chipmate and the draft surveyor will go around the vessel to take the actual draft, and actually they don't the chipmate will get the density, but he will use the density only during the final draft survey or survey report. But in loading operations, you don't need to take the use the density here because it is the actual um, time where you get where you get the draft. So you disregard the density. So you don't need the density in when trimming two holes. So this is the initial draft, and he got let's say port mid is 8.65, 65, and starboard is 8.65. So even kill. Now his departure drop is 9 meters. See, 9 meters. So in actual practice, what will be the TPC of 9 meters, that is what going to compute for getting the value of cargo to load for trimming. So in 9 meters, we have a density of 35.06. So with this TPC, so K9 to get the cargo to load will be the sinkage times 100 times your TPC of 35.6. That will be your answers will be 1,227, and the what we had was 1,212 because uh, we use the density of 1.012. That's why it is less. But in actual practice, you don't use the density because in reading this actual initial draft, you already know that that is the present density. So you can compute the actual uh, how much cargo to load for reaching this 9 meters. So you say 1027, we distribute it to hold 1 and 4. So 27, let's say, pulse, pulse, 1227 divide 2 pulse. So 613, number 1, and 614 in number 2, with a total of 1027. 1027. So here 1027. Wait, I'm sorry. Here 1227. So 1027, when you load 1227, your sinkage is 35 and your draft is 9. Then you go to holes number 2. Your cargo will be 1227, and he says how much. He say your trim will be 0.24, and he says in number 1 you load 614, 613. Okay, 613, 613, 613, and number 4, hole number 4 will be 614. So with that, your drop forward will be 8.88, and your up drop will be 9.22. Your main drop will be 9 meters, and your trim is 0.24. So your mid is 9 meters and your main is 9 meters. So you have zero deflection, which is the forward drop is 8.88 and your up drop is 9.12. You have a trim of 0.24 and your main drop is 9 meters and your mid drop is 9 meters. So you have a zero deflection. So take note of this drop when we load 1227. See, and in hold number 1 is 613 and hold number 4 is 614. So by using this density of 1.012, your recommended cargo to load is 1212. So if we load this in hold 1 and 4, so hold number 1 will be 606 and 606 in number 4 respectively, and your departure drop will still be the same. Forward drop will be 8.88 and your up drop will be 9.112, and your trim will be 0.24 and your main drop of 9. So your flexion is 0. So by because by using this formula or this problem, stops only up to the what's how much cargo to load. But while in program, this program, you will know how much you will load in number 1 and number 4, and you will have a forward draft and aft draft. So same with this one, and you will have forward draft and aft draft. So um, the I will stop here. I hope you will like this presentation. And if you have any questions, please comment right down below. Please like, share, and subscribe. Thank you very much.